welcome to True Projects. In this video, we are going to discuss about the project which is LRS PKI, a novel blockchain-based PKI framework using linkable ring signatures. So before getting into the execution, first let's understand what is the project about. So if we have to do online transactions, personal identity verification is important. And how do we get this personal identity verification? Through digital signatures. So these digital signatures, they serve as a critical component of personal identity verification and which is important for the online transactions. And these digital signatures, they are issued by the central authorities who are also called as CAs. And these CAs, they enable individuals to perform secure banking and also the other online activities. But here the problem is if a CA gets compromised or if he acts maliciously by issuing a fake certificate to attackers, these fraudulent certificates can be used to breach the banking and also financial systems, and this poses a substantial security risk. And moreover, traditional systems which uses centralized servers to store these certificates, they are susceptible to attackers, unauthorized modifications, and also crashes, leading to potential service disruptions. So, to overcome all these, the project proposes a novel public key infrastructure framework linkable that leverages linkable ring signatures and a blockchain technology. So, in this project, we are leveraging public key infrastructure framework, which is using linkable ring signatures with the blockchain technology, and we're using specifically Ethereum blockchain technology. So by using LRS, the framework ensures that the both user and also the CA details are embedded and also they are linked with the hash certificate. And this linkage allows for the robust verification, which ensures that only legitimate certificates are validated. If CA issues an intelligence that is illegal certificate, the CA's details can be extracted from the signature, making it possible to identify and hold the CA accountable. So through this project, security and integrity of the digital certificates increases. So moving to the part of blockchain. Blockchain, what is blockchain? Blockchain, it is a decentralized digital ledger and that records transactions across network of computers. And each transaction is grouped into a block which is linked to the previous block forming a chain. And this chain is immutable and also transparent, which means that once a transaction is recorded, it cannot be altered or it is not visible to the all participants. And blockchain technology ensures security through cryptographic hashing and consensus mechanisms, which allows for the trustless and tamper-proof record keeping various applications from cryptocurrencies to the supply chain management. So to address the issues of centralization and tampering in this project, we are employing blockchain technology. So the blockchain's decentralized nature, it ensures that the data is distributed across multiple nodes, which provides the redundancy and continuous service availability even if some nodes fail. Additionally, tamper-proof characteristics of blockchain ensures that any attempt to modify a stored certificate, it will be detected due to hash code mismatches, preserving data integrity. So the proposed system includes modules for key generation, certificate signing, verification, and linkage, enabling the creation and validation of the ring signatures. So certificates including image-based ones are stored in the interplanetary file system that is called IPFS. With their reference hash codes are saved in the blockchain. And this hybrid approach ensures efficient storage and retrieval while maintaining security and also integrity. So by integrating these technologies, the project aims to provide a secure, decentralized and tamper-proof PKI system mitigating the risks associated with the compromised CAs and centralized certificate storage. So to manage, store all users' identities, the project is using IPFS file storage server. If more certificates are stored, the server memory will be exhausted. So to save the memory, all certificates are compressed to reduce their size. And their size reduction requires less memory and it can save some memory on the IPFS server. So we heard about PKI and LRS, right? So before knowing PKI, first let's understand what is LRS. So LRS, it is a linkable ring signature. Linkable ring signatures, they are the type of cryptographic signature scheme that allow a signer to anonymously sign a message on behalf of group of users while linking multiple signatures to a common group. And in this project, LRS is used to enhance the security of digital certificates with the public key infrastructure framework. Specifically, LRS is employed to embed and link user and certificate authority details within the hash certificate. So, this linkage ensures robust verification while only legitimate certificates can be validated. If a CA issues an illegal certificate, the details can be extracted from the signature, enabling accountability and preventing fraudulent activities. Moving on to the PKS, PKS is a public key infrastructure. It serves as the underlying framework for managing digital certificates, cryptographic keys, cryptographic measures to ensure secure electronic communication, and verifies the identities of users, devices, and services across networks, notably the internet. So, by leveraging PKI, the project facilitates the issuance, management, and verification of the digital certificates using advanced techniques called linkable ring signatures and the blockchain technology. So these technologies enhance the security and integrity by enabling secure and trusted communication between parties while ensuring confidentiality, integrity, and authenticity of exchange information. Moving on, we have used Ganache as a user-friendly interface for Ethereum's blockchain activities. So this Ganache, it displays the accounts, transactions, and smart contracts of the Ethereum blockchain activities. And moving on, here we have used MetaMask as the Ethereum wallet. It shows the balance, that is the ETH which we have after the transactions. Furthermore, to implement this project, we need software and hardware requirements. So coming to software requirements, we need Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, MetaMask of Chrome extension. And backend languages which are used are Python, JavaScript, and Solidity. And the hardware requirements are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. And front-end languages used are HTML, CSS, JavaScript, and Bootstrap. And the framework used is Django. So this is all about the project. Now let's execute it. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of a project. Let us understand each of them, how will they be used in the project. So coming to this PKI folder, inside this folder there are Python code files that are intended to be dynamically loaded into the project code during runtime. And here we have PKI app folder. So this folder comprises of three different folders. One is static, other one is templates, and the other one is Python code files. So coming to the static, it contains files related to CSS, JavaScript, and Bootstrap files. So these files, they contribute to the visual and interactive aspects of the application. Moving to the templates folder. Within this folder, we will find all the HTML pages used throughout the project. And it includes pages like index.html, home.html, and more, representing various sections of the website. Coming to the Python code files, so these files will be executed during the runtime of the application, which supports the project's functionality. And this is the database file. And here we have IPFS application. We use this for storing the images in the blockchain. And this is the manage.py file. It is a command line utility that comes with the Django. And it provides various commands for managing Django projects, including tasks like running the development server, creating the database tables, applying migrations, and more. And this is the run server.bat file. Instead of executing the project through command line interface, we have created this Windows bat file. So to execute the project, we need to double click on this to start the Django application. And moving on, this is the Solidity code file. It handles data structures, functions, and events with modifiers for validation. And this is start ipfs.bat file. So if we double click on it, IPFS server will be started. So to execute, we need to host the server first. For that, we need to open the Ganache. So here we can observe that server is started. Get back to the application. So first we have to host the, that is we need to run the IPFS server. For that, double click on this start IPFS bat file. So IPFS server is started. Now get back to the code folder. Now double click on run server.bat file. So here we can observe that manage.py file is compiled. And this Django framework has hosted the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. And now copy this local link provided by the framework and paste it in any web browser. So I prefer Google Chrome, so I'll paste it in that. Paste the link here. At the end, type index.html. And now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Django framework. So here in the home page, we have two different links. One is CA login here link and the other one is user login here link. So first we need to log in as CA and issue the certificate to the user. Then user can log in and view his certificate, which is issued by the CA. So click on CA login here link to issue the certificate by the CA. So provide the username and the password of CA. And now click on login. So CA has logged in successfully and he can do various tasks. One is he can issue the certificate, he can view all the certificates which he has issued, and he can see the sign time graph and also he can see the extension compression graph. So first we need to click on issue certificate to issue the certificate to the users. So click on that. And here we need to provide all the details of the user to issue the certificate. So the username is Kiran and provide the password, contact number, gender. So the gender is male. Here we need to provide the email address and the address. Click on choose file to upload the certificate. So I'm selecting this image, click on open. Here we can observe that the certificate is loaded. Now we need to click on submit. So here we can observe that the certificate saved in the IPFS with this hash code. So this is the hash code which represents the certificate which is saved in the IPFS. And this is the certificate's ring signature. So this ring signature is nothing but a digital signature. So this ring signature, it lets someone sign a message as the part of a group without revealing exactly who is in the group signed in. And this is the total certificate signing time graph. So this is the time taken to generate the ring signature for the certificate. And this is the normal size of the certificate and this is compressed size of the certificate. Let us issue the certificate to other users. So the username is Kishore. Provide the password and provide the contact details. Select the gender. Provide the email address. Enter the address and now click on choose file to give the certificate. So let us issue the certificate. Click on open. Here we can observe that the certificate is loaded. Now click on submit. And here certificate is saved in the IPFS with this hash code. So this is the hash code which represents the certificate which is saved in the IPFS. And this is the ring signature for that certificate. So this is the ring signature. And this is the total certificate signing time. So this is the time using which the ring signature is given. And this is the normal size of the certificate and this is the compressed certificate size. So normal size of the certificate is higher than the compressed size of the certificate. Now we will view all the certificates. So click on view all certificates. So here we can observe that CA has issued certificate to the two users. One is for the user Kiran and another for Kishore. And here are the details and this is the certificate name and this is the uploaded time. And here we have IPFS hash code for the uploaded certificate. And here we can observe that there is ring signature generated for this particular certificate, which is issued to the user Kiran. Similarly, we have for the user Kishore also. So these are his details and this is the certificate name. And here is the uploaded time. And this is the IPFS hash code of the Kishore certificate. And this is the ring signature and this is the certificate which is issued. So now we will see the sign time graph. So click on that. So from the graph, we can observe that on x-axis, we have two different certificates which are issued to the users. And on y-axis, we have time graph, that is how much a certificate has taken to generate the ring signature. So we can observe that certificate 1 has taken less time and certificate 2 has taken more time. It is because it may be of image sizes more. So now we will see extension compression graph. So click on that. So this is the normal storage size and this is the compressed storage size. Now click on log out and log in as user. So click on that. Here we need to provide the user's details to log in. So first we will log in as a user Kiran. So give the username and the password. Now click on login. We can observe that user Kiran has logged in successfully. And now we need to click on certificate validation so that user Kiran, he can validate the certificate which is issued by the CA. So click on that. So these are the certificate details. So now let's see how the data is stored in the blockchain. For that, we have to open the Ganache, click on blocks. And here we can observe that the data is stored in all the 13 different blocks. So for each block, we have date and time, that is when that particular block is stored. So let us open block 13, for example. Here we have block hash for the block 13, and this is transaction hash. If we click on transaction hash, it will redirect to these details. So here we have sender address, to contract address, gas used, gas price, gas limit, and transaction data of block 30. Similarly, we have for all the other blocks also. And by using these blocks, we can retrieve the information. Now get back to the application. Now let's check the deductions of the ETH price with the each transaction. For that, we have to open the MetaMask, which is the Chrome extension. So here in the MetaMask, we can see that I have balance of 99.9959 ETH in my MetaMask wallet, which represents the deducted amount after recent transaction. And in the context of blockchain transaction, they refer to the actions or the operations that are recorded on the blockchain ledger. So now get back to the application. Now click on revoked certificate link to revoke the certificate. So click on that. So user, he can revoke a certificate if his private key is compromised, lost, outdated, or suspected of misuse to maintain the security or integrity. Let us assume that the user's certificate is compromised, that his private key is compromised. So let's upload the certificate and revoke the certificate. So click on choose file. So let us upload this image, click on open, and now click on submit. So here we got the certificate revoked in IPFS with the new hash code. So this is the hash code for the certificate revoked in the IPFS. And this is the certificate new ring signature, which is revoked. Now click on log out. Similarly, user Kishore, he can also do the same. So the LRS PKI project, which has introduced robust public key infrastructure framework and using linkable ring signatures and blockchain technology. So by integrating this LRS, it has enhanced the certificate security by anonymizing signatures within groups, thereby protecting against compromised certificate authorities. So utilizing blockchain, it has ensured decentralized and tamper-proof storage of certificates, which has ensured data integrity, resilience against centralized server vulnerabilities, and this approach promises a secure and reliable system for managing digital identities and transaction online.